Good day, everybody. This is Chris with the Ancient Scholar, and today what I'm going to do is I'm going to be doing a follow-up video. This is rather a revision video. Somebody pointed out that there is an error, or I had failed to mention something in one of my videos, and this is in regards to the video Barbiturates and Benzos Part 5, I believe, and I'd have to give a shout-out to a YouTube member. I hope I announced the name, his or her handle correctly, but I believe it's Ameaklim. User Ameaklim asked about sodium thiopental and had asked me a question regarding its chemical structure, and basically it said, hey, isn't there a sulfur atom in sodium thiopental, which is one of the rapid-acting barbiturates? And when I had talked about it, this is the molecule that I had showed you guys right here. Okay, and just ignore this here, and I basically just shown you this molecule here, and that user is in fact correct. I should have attached a sulfur atom, and the sulfur atom actually attaches right here to this carbon, which is a double covalent bond to a nitrogen here, and a covalent bond to a nitrogen and a hydrogen group here. And of course, you have your carbonyl, double bond carbonyl groups here. You still have your carbon chain that comes off, and you have three methyl groups: a methyl group here, a methyl group here, and then a methyl group that comes off of this sp3 hybridized carbon here at the back end of the ring. So what happens is a sulfur atom is in fact covalently bound to the carbon at the top of the ring here. And let's see if I can put that on. I'm kind of trying to do this one-handed, which is kind of a pain. So, oh Lord, all right, finally got it on. Okay, so this is actually what the structure of sodium thiopental or pentothal is. Has a sulfur atom here, and the sulfur atom actually has an additional electron. So the sulfur atom is actually negatively charged. So this part of the sodium thiopental molecule is polar here. There's actually a negative charge here. And that's actually where the term sodium thiopental comes from. So here I have a sodium ion, which has a +1 charge, and then I have a -1 charge on the sulfur atom here. And so what this does is this causes an ionic bond, and that's what this little long guy, just single long guy here, is just symbolizing an ionic bond. So you actually have an ionic bond between the sodium ion and the negative charge of the sulfur. And that's why we call this sodium thiopental, because I have the thiopental molecule ionically bound to the sodium. And this helps dissolve this in water, just like sodium chloride would dissolve in water. This can dissolve in water. So that is the major revision there. I want to thank you for pointing that out, because that is actually really important. It's an important physiochemical characteristic of sodium thiopental. Now, it doesn't change the fact that overall, once this gets into the body, overall, this is still a highly lipophilic molecule, and whenever you see methyl groups, CH3 groups, the really methyl groups and long carbon hydrogen chains really do scream lipophilic. And sodium thiopental just so happens to have three different methyl groups in addition to a carbon chain coming off of the main cyclic area here in this barbiturate. So this is highly lipophilic. So just like I talked about in the prior video, this is very good at penetrating membranes, particularly getting into the central nervous system. Can rapidly get into the central nervous system. So this has a very rapid onset. But because it is so lipophilic, it doesn't necessarily stay in the central nervous system. It has a tendency to rapidly move out into other tissues that have a decent vascular supply, so muscle and even fat. In fact, this will rapidly redistribute into adipose tissue of the patient. And so what that means is, yes, it can get into the central nervous system very quickly and have a very rapid onset, but then it is very good at leaving the central nervous system. Has a very high lipid water partition coefficients, like 10 or 12. It's pretty high. So it will partition itself in other lipid compartments of the body and rapidly shift out of the central nervous system. And so it has a very quick onset, but its duration of action is very short because of that. It is metabolized. It is metabolized into a rather inactive metabolite. I think the major metabolite is pentobarbital is a major metabolite that can then be eliminated. So as you might imagine, people that have very high levels of adipose tissue, they may have a even shorter onset and shorter duration of action, whereas people that are very lean and have very small amounts of adipose tissue, you can imagine that if they don't have the fat that some other people do, that there will be less fat for this molecule to redistribute into, and so it will stay in the central nervous system longer, and you can have a prolonged duration of action. So that's something kind of noteworthy with this. Okay, guys, I'm going to go ahead and cut it off here. Thank you again for bringing up the point that I did not mention, that there was a sulfur atom there, because it is actually an important characteristic of the sodium thiopental molecule. As always, thanks for hanging in there.